All right, so I didn't ask you this question on the quiz, but it's the key concept. When you look at something and say it's quadratic, your brain, the first thing you should say is, oh, there are 3 ways to solve a quadratic. I could set it equal to 0 and factor it, so solve by factoring. I could take the square root of both sides if it's the right format. Or third, I can use the quadratic equation. So today is the quadratic equation. In Algebra 1, I'll give you the equation on your quiz or test. You'll have to know how to use it. In Algebra 2, you'll have to have it memorized. So, but Algebra 1, I will give it to you. However, every problem you do, I do want you to write it because I want you to get familiar with it. If you can learn it now, so much the better. But it is a little complex, so I will give it to you on any quiz or test here in Algebra 1. All right, so solving using the quadratic equation. The key to it all is the A, the B, and the C of standard form. The A, the B, and the C of standard form. So if you look down below in the actual formula, it's X. By the way, if you're solving for X, what if the variables were all Z's? It would be Z equals. What if the variables where all the X's are up there were T's? It would be T equals, right? What if all these letters, instead of this being an X and that being an X, what if they were a Q? Then this would be Q, right? The independent variable. So X equals negative B plus or minus square root of B squared minus 4AC all over 2A. Notice the A, the B, and the C in the formula. What do they correspond to? The A, the B, and the C of standard form. Now, as always, you got to take note, you read the A, B, and C when it's equal to 0. If it's not already, you make it equal to 0. And then you'll be able to read the A, B, and C. What is the A? The coefficient, the multiplier of the squared term. What is the B? The coefficient, the multiplier of the variable to the first power term. What is the C? The numbered term. All right, and I'll show you all that when we get into actually using the quadratic equation. Some students like it better than all the other methods because it's just something you plug into. So really, technically, you're supposed to use the quadratic equation to solve when you can't use the other 2 methods, because quite honestly, the other 2 methods are more efficient. You might say, well, Mr. Scarfi, why don't we just learn the quadratic equation? Forget that other stuff. Well, here's the problem. Any equation 3rd degree or higher, the variable's cubed, has to be solved by factoring. First method we learn in solving a quadratic. Lots of 2nd degree and higher equations can be solved by taking the root of both sides. 2nd method we learned. The quadratic equation only works for quadratics 2nd degree. So that's why you just don't learn the quadratic equation and nothing else. We got to learn those other 2 methods because not only do they solve quadratics and not only are they the most efficient way of solving quadratics, they solve a whole host of other things as well, and we learn them on the easier, most simplistic form of those equations. Okay, so that's the idea and that's the concept. So again, use the other 2 methods first if you can, just by way of review. What is that factoring? And again, when I say factoring, it's the method where you set the function equal to 0, you factor, set each factor equal to 0, and solve. 2nd methodology, taking the square root of both sides. Again, if you're just thinking roots. So mental thought, it would be, hey, what are my 3 methods? Factoring, roots, and the quadratic equation, right? Simple thoughts as you go through in your mind your 3 possibilities, the 3 tools you have at your disposal for solving quadratics. Now look, if you don't have those thoughts in your brain, you're going to be in a really sad shape, but it's not hard to have those thoughts. You just got to learn that. Just got to memorize it if you need to, all right? Factoring, roots, and then, of course, today, the quadratic equation. So let's get into it. Let's go ahead and solve using the quadratic equation. Some call it the quadratic formula, but it was way in the beginning called the quadratic equation, and I think that's more common. I think your book says the quadratic formula. Either way, it's the same thing. All right, example A. This thing's already in standard position. How do I know that? The squared term is first, the first powered term is second, and the thing equals 0. Good. That's standard form for a quadratic. It's got to be in standard form. We're ready to read the value of the A, B, and C's. And look, I made it easy on you. I used color, and I included the ones that usually are not there. Do you agree? Do we usually have ones there in front? No. But just so you understand, the A in this one is a 1, right? Normally you wouldn't see that 1 there. What's the value of B? Say it if you know it. So I heard 1 and -1. Which is it? -1, right? We already learned keep the sign with the coefficient. -1. And then the C is a -12. All right, and from there, we'll just plug it in. Now, I chose these values on purpose, so stay with me. I'll try to go slow enough for you to stay with me. Use your black here, those of you that are smart enough to have 4 colors. And keep your black. See this negative in front of the B? Keep that black. Here's what some students do. What's our actual value of the B itself? It's a -1, isn't it? So all they write is -1 here. Well, that's not true, is it? It's the negative of the formula, then the -1 of the B. Right? I did negative, the opposite of the B value. What's the opposite of -1? And isn't that going to give us a 1 minus a -1? Everybody clear on that? Do you see that? Because this is the first sticking point where students will make a mistake. So this is the first thing that'll get a student. But it's not a hard thing. Just remember the negative is part of the formula. And then comes the B value. So negative and -1, the actual value is 1. Be careful there. Next, notice the plus minus. Because again, we need 2 values, right? Because this is quadratic, and how many solutions do quadratics have? 2. So we need that. Next comes the square root symbol. We're doing a radical. And all the rest of this stuff is in the radicand. So I'm going to take my green, and I'm going to use a parentheses. You know what? Here, you guys, I'm going to try to think of how your calculator will punch this better. I think you're going to have to use a parentheses around the whole discriminant. So I'm going to do that in red, and then we'll do the rest. We'll follow the colors. Just stay with me. I think this is the way you're going to need to punch it. Take your green, do the B, the -1, then your black, and square it. So do you agree that's B squared? -1 squared is B squared. Are you with me? B squared. Okay. Back to black, right? Because your formula now has a black minus sign. Now, before I go any further, I'm not sure you need these 2 parentheses with your calculator. I think most of your calculators these days, if you do -1 and this, do you have to do the square button first? I mean, see, every calculators are different these days than they used to be. If you're going to do, let's say you were just punching this all on its own. Let's say you had a -5 squared. Go ahead, everybody do this. Punch that in. Now, again, we mean a -5 times a -5. The answer should be positive 25. So how do you punch this? Do you do the squared button first, and then the -5, or the -5 and the squared button? Okay, so if you do -5 with no parentheses and the squared button, what does your calculator tell you? Okay, so you have to use that parentheses. Okay, so here's another parentheses. So look, this is what you got to punch. Square root button, parentheses, parentheses, -1 squared, close parentheses. Because you got to get, we'll work on that when we get there. All right, anyhow. And then we have another parentheses. And we got a black 4, right? We got a red 1. I'll stick it in there. You don't really need to worry about ones. And I'm going to use a raised dot here times a -12. We're going to close the black parentheses, and then we're going to close the red parentheses. I mean, calculators today make it even a little bit more complicated than it needs to be. I'm going to show you an alternate way of thinking of this in a minute. And maybe that's better than trusting you're going to punch everything in correctly. All right, let's finish the bottom, then I'll talk about those two methods. On the bottom, it's 2 times a, so that's 2 times a 1. So where are the two places where a student will mess up? Forgetting the negative on the negative b, and secondly, not punching this correctly. And you know what? I should just back up a little anyhow, because we really don't want a decimal answer. So let me go ahead and show you what you need to do. I'm actually a little ahead of myself with all that punching and made it harder than I need to make it. Okay, so let's just work our way through. Negative and -1 is a positive 1. You agree? Okay. Let's keep the root and do the two parts. I hate when I do this. I made things more complex, and I'm supposed to make them easier on you guys. Tell you what, just scribble through this, the red parentheses. We just don't need those. Everything else is good. If we were going to get a decimal answer, we'd be fine there, but we're not. Okay, so punch in your calculator -1 squared. No problem. You know it's going to come up and be a 1. All right, and I'm just going to do that in black. Here's where the problem comes into play. And the back parentheses is really key. So now you have a negative, the 4 times the 1 times the -12. That's what you have next. Now look, do we bother to write plus a minus? No. But is technically that plus sign there? Yes. So you got to be careful. All of this value right here gets added to the 1, right? The -4 times the a times the c gets added to the 1. So if you do it in 2 steps, if you leave the negative out, then do 4 times 1 times -12, and of course you get -48. And the bottom is a 2. All right, so I hate to show you so many different variations, but again, your minds work a little differently. Somebody else would have done this part. The -4 times 1 is -4. -4 times -12 is, and instead of doing negative a -48, they would have just done positive 48. Is that not the same thing? Yeah, so either way is okay, but you gotta make sure that you add it. Here's what I see students do. They get positive 48 and they say 1 times 48 is 48. Is that what we have, 1 times 48? No, we have 1 plus 48. It's a big difference. The b squared and the whole rest, the -4ac, get added together, not multiplied. So don't make that mistake. That's the mistake I see students make. All right, so just to be clear, here's where we're at. 1 plus or minus the square root of 49 divided by 2. Do you agree? Because minus a -48 is a plus 48, or if you do -4 times 1 times -12 is a positive 48. Okay, Obviously, can we simplify the radical? I hope you're saying yes. What is the square root of 49? 7. Yes. Do they always work this way? Usually not. To be quite honest, anytime you can take the whole root, that means you could have solved it by factoring, or you could have solved it by taking roots of both sides. This one you could have solved by factoring. That's okay, we're trying to learn the quadratic equation. Am I done? No. Do you remember back to 2 solutions? Well, we still need 2 solutions. And because there's no radical, we can get those 2 solutions. So remember, the one time you use the plus sign, right? And the other time you use the minus sign, right where it is. We have 1 plus or minus 7 divided by 2. Couple more points of emphasis. Notice the 1 plus the 7 is all over the 2, right? That fraction bar, it's the whole numerator. All right, so the left is what? 8 divided by 2, and that's a 4. And the right is a negative 6 divided by 2, and that's a negative 3. And those are our 2 solutions. X equals 4, x equals negative 3. Okay, before I go any farther, just watch for a second. I just want to show you that, of course, the method doesn't matter. I'm going to solve this by factoring. X and x. I've got a negative 12, but my outers plus my inners have to add up to negative 1. How about if I use a negative 4 and a positive 3? That gets my outers to be negative 4, my inners to be positive 3. That gives me a negative 1 in the middle. True? What happens when you solve that factor? You get x equals what? Negative 3. And what happens when you solve that factor? You get x equal 4. And of course you're going to get the same answer solving it that way. Again, normally do we solve quadratics that you can factor by using the quadratic equation? No. But it makes for simpler understanding of learning the process in the middle. For homework tonight, you'll get some like that. Now look, you're supposed to solve these by the quadratic equation. That's what you're learning. So don't be solving them by factoring. We want you to learn the quadratic equation. All right, let's go on, do another one. So your first thought, is it in the right form? Earth to Daydreamers, is it in the right form? Yes. Good, we're ready to read A, B, and C. So go ahead and write your values for A, B, and C. I'm still color-coded to help you out. So unless you're colorblind, that's pretty easy. I found a lot of students like to do this first off on the side and just list their values instead of reading it off of it. It doesn't take all that long. You're probably going to take about 5 or 8 seconds to do it. And a lot of students find it worth the 5 to 8 seconds to keep things straight. Okay, so now let's go ahead and execute. So I want you to go ahead and sub in the values. Go ahead and take it to the point where you have the radicand, but don't do any simplifying. Get one number in the radicand, but then stop there. I'll be doing it up here while you're doing it there, so you can look up here if you're concerned if you're doing things correctly. So you're following the pattern. There's a quadratic equation right there for you. So again, if you can do it, so much the better. But if you need help, look up. If you're concerned if you're correct on a step, after you finish it, look up. Now, your steps may not look exactly like mine because you may choose a little bit different methodology. But when you get to the last step that I asked you to stop at, it should look the same. Did you end up at -3 plus or minus the square root of 81 over 4? You should have had a 9 plus a 72 or a 9 minus a minus 72, right? Which is still a 9 plus a 72. So how many ended up at the square root of 81? Okay, so some of you did not. Are you figuring out why you didn't get the square root of 81? Okay, figure out why. What did you do wrong that caused you not to get 81? You got to figure that out now, otherwise you're going to keep making that mistake over and over again. All right, go ahead and finish it. Go ahead and finish it. Again, if you want to, you can look up. And you should end up at 3/2, always reducing, right, and -3 as you split it up. Questions before we go to the next one? Questions? Questions? Okay, so again, you got to be careful in understanding how to get that square root of 81. No questions? All right, next one. So in this one, you can see that, again, it's in standard form. All right, go ahead and put the A, B, and C values. Go ahead and plug it in and try to take this one to the end. And again, I'll try to put things up here as well. Everybody look up at the screen. On your last test, on the front page, as there have been on every test you've had, in the rules section, there was this rule. 5x plus 6y divided by 2z. Now, probably a third of you got the rule wrong. You're going to have a problem finishing this because you got the rule wrong. Once you got the rule right, you said 5x over 2z plus 6y over 2z, and you reduced the 6 and the 2, and you ended up like that. That is this situation, and that is how we must finish this. Okay? Again, everything we learn is for a purpose, but if you don't understand something and you leave it where you don't understand it, it keeps bothering you again and again and again and again. Which is why that rule section is the most important part of every test. And some of you keep missing the same rule over and over and over again, and you don't care. Well, again, we have to split this up. -8 over 2 plus or minus 2 times the square root of 13 over 2. That is the proper way to finish this. Now we can reduce the parts. Now, question. How come on this one I didn't make it 2 equations? Can somebody answer that question? Why didn't I make this one 2 equations and solve each equation? Why not? Why am I not splitting this up, Andrew?
Because once you work it out, it's going to be the same thing, just with the negative sign.
True, but can we be a little bit more specific of why I'm not going to split this up right now? Why am I not going to split this up now? Anybody? All right, here's what I mean. Look, when we got to here, Windows, when we got to here, didn't I split it up into two equations to finish it? Right? So how come I'm not going to do that now? How come I'm not going to do that right here? Adam? It's not, we don't split it up because of the denominator, but at least you're thinking. Josh? Say again? Because the square root can't be simplified, right? It was the same thing we did earlier when solving by taking the square root of both sides, right? Remember, once you have that radical, if you split it up, what do you get? -4 plus the square root of 13, that's as far as you can go. And the other equation is what? -4 minus the square root of 13, and that's as far as you can go. So there's no value to splitting it up, so you're done. You just leave it together. Both answers are together as one. Again, if you want to split it up, you can, but you're just wasting your time. You're just wasting your time. All right. So let's get to a couple other things. So go ahead and write the values of A, B, and C and stop. Just write the values of A, B, and C and stop. A, B, and C and stop. All right, so on 3, give me the value of A. 1, 2, 3.
2.
On 3, give me the value of B. 1, 2, 3. On 3, give me the value of C. 1, 2, 3.
3.
I heard 4, 3, and -3. So which is it?
4.
It's, of course, -3, right? Because the 3 is on the wrong side, and of course we have to add a -3 to both sides to get this thing, right? So all 3 of the previous ones I said, oh, look, it's in the proper form already. Now, again, if you don't do that, you're going to get the problem wrong. So C is a -3. All right, go ahead and work it. You work it. I'll work it at the same time. If you need help, look up. If you want to check step, look up. But try to do it on your own if you can. -1 plus or minus the square root of 10 over 2. Anybody concur? Okay. And again, try to go back and analyze if you made a mistake. Did you get minus a minus 24? Okay, good. Did you get then 40? Did you simplify the square root of 40 into 2 times the square root of 10? Good. Did you split it up? Reduce the front, reduce the back. Hey, be careful. A -4 divided by a +4 is not a nothing. It's a -1, right? If that would have been 4 over 4, it wouldn't be a nothing. It'd be a 1, right? Anything divided by itself is 1. Don't forget the 1. I see students do that occasionally. How many got that correct? Okay. And again, if you didn't, you're finding out what spot got you. You got to look and say, what spot's getting me? Okay, why am I getting it wrong? What am I doing that's not right? Questions. Questions. See, you won't ask, so I can't help you when you don't ask. I know you want to come by later and ask, but I just spent 40 minutes, 30 minutes trying to get you to understand, and then you're going to come back later, and I got to spend 20 minutes again trying to get you to understand because you're afraid to ask in class. You've got to get over that. Okay, here's one with R's for all you pirates out there. R. All right, A, B, and C. So go ahead and knock out A, B, and C. You can look up. Hopefully those are the values you got. All right, set it equal to 0. So you added a negative 5r to both sides. You added a negative 4 to both sides, right? That made your A a 2, your B a negative 5, and your C a negative 4. All right, go ahead and knock that one out. It's our last one, isn't it? Okay, good. So go ahead and knock that out, and I'll, again, do it up here. Look if you need help. By the way, do you write x equal? What do you write? R equals. Yep, we're doing R. What happened in my parentheses? You in the wrong place. See, 57 is divisible by 3, right? But 3 times 19, and are we going to have 2 of anything? Nope. So that one's done, right? Right there. 5 plus or minus the square root of 57 all over 4. All right, before you pack up, let me show you something. Everybody just stop and pause where you're at. None of my examples involve a concept. Don't write this, I just want you to watch. Let's suppose you get down to the end and you're like this. Let's go negative 10 plus or minus 3 times the square root of 7 over 5. So how would you finish this off? Can you do anything with that 5? Can you just do that? Does that work? No, because remember the split thing. So that's not true. However, you could, if you wanted to, do this. And there's a time when this is the preferred format. This part will happen, right? But the other part stays divided by 5. And that would be a true answer, negative 2 plus or minus 3 times square root of 7 over 5. All right, you got your homework, and learn it tonight. Get it down tonight.